three different objects of masses m1, m2 and m3 are allowed to fall from rest from the same point along different frictionless paths. The speed of the three objects on reaching the ground will be in the ratio of. Okay, so let us try to understand the question. So this complete playlist will be based on solving questions which are based on ratios. Okay, so what is that? How to solve them? We'll see as we go through the playlist. So let us assume that there are three bodies here. So this is body 1. They are dropped from the same point. Okay. Which is as equal as saying they are dropped from the same height. Okay. Now the weight of the body is, the first body is m1, weight of the second body is m2, and weight of the third body is m3. Alright. Now what I'm going to do is, I'm going to take you through the process in the mathematical way. So let us say the velocity, let us consider the body for the motion of body, or let us say for the body m1, the body is dropped from rest, right? So here the final initial velocity u will be equal to 0 and it will hit the ground with some velocity v, right? So initial velocity is equal to u, which is equal to 0, and final velocity is equal to v. And what is the distance traveled? See, the distance traveled is the height from which the body is dropped. Let us take that as h. Is it given? No. Okay. So let us take that height as h. And when it hits the ground, right? When it hits the ground, we know that the body will be hitting the ground velocity v, which will be accelerated and not decelerated, which will be accelerated by acceleration due to gravity. Okay. All right. Now, for the first body, let us take the equation of motion. V square minus u square is equal to 2as. All right. Now, what is v square? The final velocity, which is here is v. So we can write that as v square minus u square. What is the initial velocity? It is 0. So we'll write as 0 square is equal to, this is 2 into, what is s? S is the height, right? S is the height, the distance traveled. So the object is dropped from here. It means it will come down to the ground, which means the body has traveled that much distance, which is equal to the height of the place where the body was dropped. Okay. In which case, this becomes 2a into s into h. Now, what is a? See, there are many ways of interpreting the concept here, but what I generally follow is, since the body is dropped, this actually results in increase of velocity, right? Velocity will keep on increasing, which means acceleration due to gravity acts as acceleration and not deceleration here. Okay. So I'll take this as positive g. In which case, what do we have? We have the equation as v square is equal to 2gh. Now, see, 2 and g are constant, right? So if v square is equal to 2gh, then all what varies is v square is proportional to h. And if you take if you take the power of 1 by 2 on both sides, what do you get? You get that v raised to the 1 raised to v raised to the whole raised to 1 by 2 is v. V is proportional to h raised to 1 by 2, or we can say that v is proportional to root of h, right? So this is the relationship between velocity and height. Now, it can thus be said that the velocity of the object reaching the ground, is dependent only on height, right? So this is something we need to highlight, because it depends only on height. Or otherwise we can say that it is not dependent on any other thing which includes mass, and is independent of and is independent of what? And is independent of mass, which means the ratio, right, the ratio will basically be equal to, okay, let me explain that also. See, for m1 the height is h, for m2 the height is h, for m3 the height is h, which means for v1 it is proportional to root of h, for v2 it is proportional to root of h, for v3 also it is proportional to root of h, in which case what is v1 is to v2 is to v3 equal to root of h is to root of h is to root of h, which basically is equal to 1 is to 1 is to 1, which makes the correct answer as option C. A body falls from height h is equal to 200 meter. The ratio of distance traveled in each 2 seconds during t is equal to 0 to t is equal to 6 seconds of the journey is. Let us visualize the concept first and then we'll see how to solve it. So our body is dropped here. The height here is h, which is equal to 200 meter. Since it is dropped, the initial velocity is 0 and it will hit with velocity v the ground. Okay. Now, if we write the equations of motion, what can we write? We can say that s is equal to ut plus half a t square. Now s is equal to u is 0, so this becomes 0 into t plus half into, I'll take it as g into t square. So s is equal to half g t square. Right, this is what we get. Now let us try to make sense of the data in the question, which is time t is equal to 0 to time t is equal to 6 seconds. Okay, see. So if you take, so if this is the, I would say time t is equal to 0, time t is equal to 1, t is equal to 2, 3, say 4, 5, and 6. Okay. Now, okay, let me mark the names also so that will become more clear to you. So A, B, C, D, E, F, G. Okay, so this is the position and the time. Okay, now distance covered. Okay, distance covered in the first 2 seconds. What is that equal to? In the first 2 seconds is equal to AC, right? Which is this much of distance. Now, what is that mathematically numerically equal to is half into g into 2 square, which is equal to 2 square is 4, 4 by 2 is 2, so we have 2g. Okay. Now, what do we have next is distance covered in the next 2 seconds, not in the 4 seconds, in the next 2 seconds. In the next 2 seconds, which is equal to, see, what is the distance covered in the next 2 seconds? If you pay close attention, it is this distance, right? CE is the distance which is covered in the next 2 seconds. So we'll write it down, which is equal to CE. And what is CE equal to? See, this is A, this is E, and this is C. So CE will be equal to AE minus AC. What is AE? AE is distance traveled in 6 seconds. And what is AC? That is distance traveled in 2 seconds, which can be written as half G into, oh, did I take 6? I'm sorry, it is not 6, it is 4. So S4 minus S2, which is half G 4 square minus half into G into 2 square. So which actually will be equal to half into g into 4 square is 16. 16 minus 4 is 10. 10 by 2 is oh, did I make a mistake? 4 square 16. 16 minus 4 is 12. 12 by 2 is 6, right? So this is 12 into 6g. So you get 2g and then 6g. Now, in the similar way, what is, excuse me, okay. So what is distance covered in the next 2 seconds? Distance covered in the next 2 seconds would be further equal to, next 2 seconds will be equal to, what is that distance? It is primarily EG, right? It is EG that is being covered. So which is equal to EG. And how can you find out EG? EG will basically be equal to AG minus AE, right? Will be equal to AG minus AE. What is AG? It's the distance traveled at time t is equal to 6. So we're going to write it as S6 minus what is AE? We already have AE will be equal to distance traveled in 4 seconds, which is S4, in which case, what do we get? Half into G into, this can be written as 6 square minus half into G into 4 square, right? So this is 36 minus half into G into 36 minus 16. 36 minus 16 is 20. 20 by 2 is 10. So we have 10g, right? Now let us look at the ratio. What is the ratio? It is 2g is to 6g is to 10g, which basically is equal to 1 is to 3 is to 5. Which means the correct option here would be, okay, there's a minor error in the option here. It's not 1 is to 3 is to 6. It is 1 is to 3 is to 5. Particle is released from rest from the top of a tower height 3h. The ratio of the intervals of the time to cover 3 equal heights is. Okay. So what we'll do is, as usual, we'll start the question by drawing a diagram. So this is what's given in the question. A particle is being dropped, right? It comes and hits the ground. And there's a tower here. Right, so a particle is dropped from here. A particle is dropped. Okay. So the height of the tower is 3h. Height of the tower is 3h. Okay. The ratio of the intervals of the time to cover 3 equal height h. Okay, so I think I should draw this here. So height of the tower is given to be, 3h. All right, that's correct. And what we need to find is h. Say this is also h. And say this is also h. So let us assume that this much time, or this much distance h, the first 1/3 was covered in time t1, the second 1/3 was covered in time t2, and the third 1/3 was covered in time t3. Alright, so we know for a freely or for a body dropped, what is S is equal to? S is equal to ut plus half a t square. And what is further S is equal to? S is equal to, since it is dropped, u is 0. So this is 0 into t plus half into, what is a here? A will be gt square. So S is basically equal to half gt square, Or we can write this equation as t is equal to root of 2s by. So for the first, let us see, for the first one third, which is one third of h, which is h here, that is time taken as t1. So if we write that equation here, what do we get? We get not s1, we get h is equal to half into g into t1 square, right? So what do we get t1 as? T1 is equal to root of 2h by g. Let us now look at the second interval. So for the combined intervals t1 and t2, the complete distance traveled is 2h. I repeat, for the combined intervals t1 and t2, the distance traveled is 2h, in which case we can write that 2h is equal to half into g into, this time t1 plus t2 the whole square. So this will further give us 4h is equal to, or say 4h by g is equal to t1 plus t2 the whole square. So we'll get it as root of 4h by g is equal to t1 plus t2, right? So what can t2 be written as? T2 can be written as root of 4h by g minus t1. And what is t1? T1 is equal to root of 2h by g. All right. Okay. If that is clear, let us move on to the third portion. Now, what is the complete third case? The third case is that the body has reached the ground. It has traveled the whole distance, which is equal to 3h, and the corresponding time interval is t1 plus t2 and t3. In which case, 3h is written as half g into t1 plus t2 plus t3 the whole square. So what we get is 6h by g, root of 6h by g is equal to t1 plus t2 plus t3. But what is t1 plus t2? T1 plus t2 is root 4h by g, right? Root 4h by g. In which case, what is t3 is equal to? Root of 6h by g minus t1 plus t2, right? From this equation, we just transpose t1 plus t2 to the LHS. Further, t3 is equal to root of 6h by g minus, what is t1 plus t2? T1 plus t2 here from this equation is root of 4h by g. So this is equal to root of 4h by g. So now we have three values of time, which is t1 is equal to root 2h by g, t2 is equal to root 4h minus root 2h by g, and t3 is equal to root 6 minus root 4h by g. So if we now try to simplify the expression, what do we get? T1 is to T2 is to T3 is root of 2h by g is to root of 4h by g minus root of 2h by g is to root of 6h by g minus root of 4h by g. So what we'll do is we'll express everything in terms of root of 2h by g so that things become easy to calculate. So this is root of 2h by g this will be equal to root of 2h by g is to, now what I'll write here is, I'll write this as root of 2h by g into root 2, right, minus root of 2h by g is to, now moving to the third part, what I do is root of, I write 6h by g as root of 2h by g into root 3 minus root of 4h by g, I'll write it as root of 2h by g into root 2. Okay. Why did I write like this? See, it's very simple. Root AB is equal to root A into root B. Very simple. So root of say root of 4h by g can be written as root of 2 into 2h by g, which further can be written as root of 2 into root of 2h by g. Simple. Now, here what I'll do is I'll write root of 2h by g is 2. Now what I'll do is I'll take root of 2h by g common. So, if I take root of 2h by g common, what is there in the bracket? What left is root 2 minus 1 is 2. Again, I'll take root 2h by g common. So, what is left? Root 3 minus root 2. Now, what we can do is we can cancel off this root of 2h by g from every term. So, what do we get final is 1 is to root 2 minus 1 is to root 3 minus root 2, and that gives the final answer to be option D. A particle is dropped vertically from rest from a height. The time taken by the particle to fall through the successive distances of 1 meter each then will be equal to, the options remains the same as for the previous question. So the concept is almost the same. An object is dropped from a height, but this time the height is not specified, but what's given is we need to find out the time taken to cover every 1 meter, right? So let us assume this is 1 meter, this is the next 1 meter, and let us call the corresponding times as t1, t2, t3 and so on. Okay, so what is the distance time relationship here? S is equal to ut plus half at square. It is from rest, therefore this term is 0. It is falling under the influence of gravity, so we have acceleration is equal to g, which means S is equal to half into gt square, and therefore t is equal to root of 2h by g, in which case, let me write down the relationship here. So t is equal to root of 2h by g, in which case what is t1? T1 is the time taken, T1 is the time taken to cover the first 1 meter height. Similarly, what is T2? Is the time taken to cover the second 1 meter height, right? Okay, now in which case T1 would be equal to root of 2h by g, where h can be replaced by 1, so this becomes root of 2 by g. Similarly, what is T2? T2 is root of 2 into h by g, where h can be replaced by 2, which is equal to root of 4 by g. What I'll do is I'll write it as root of 2 by g into root 2. Okay. T3 will be root of 2h by g, and what's the difference? H will be replaced by 3, and this time I'll write it separately as root of 2 by g into root of 3. Okay. So okay, we have these values now. Now what we'll do is, see, time taken to complete the fall of 1 meter is, okay, I think I should denote this also, is basically t1 minus t0, right, which is equal to root of 2 by g minus root of 0, which is root of 2 by g, 2 by 0. Similarly, what is time taken to complete the fall of the second meter? It will be, see, this is 1 meter height, this is another 1 meter height, this is the third 1 meter height, this is the fourth 1 meter height. So each and every height here, every unit of height here represents 1 meter, right? Now the concept here is visualizing this part. This was at t is equal to 0 and this is at t is equal to 1, which means the duration in which it was in the air to reach this position, it's better that I name them also. So this is A, this is B, C, D and D. So the duration in which, the time duration which it took to reach from A to B is basically t1 minus t0, right? Then from B to C, again it was in the air only for this much time, right? So at C, say it is time t is equal to 2, which means t is equal to 2 minus t is equal to 1, right? So t2 minus t1 is the time in which it has fallen the second 1 meter height, right? Please listen to the explanation once again. The concept will be clear to you. In which case, what can we write? This as equal to t2 minus, this will be equal to t2 minus t1, which is equal to, what is t2? From here we have root 2 into root 2 by g. Now let me, for those students who couldn't get the concept, let me make sure that I'll explain the concept very clearly in the third step. So time taken to fall the third consecutive meter is equal to, what is that? It's equal to root is equal to t3 minus t2. And what is t3? We have it here, is root 3 into root 2 by g minus, what is t2? T2 is here, t2 is this value, which is root 2 into root 2 by g. Now that we have derived these values, let us find out the required ratio, which is t1 is to, which is t1 minus t0 is to t2 minus t1 is to t3 minus t2, right? Now, what is t1 minus t0? It is root of 2 by g is 2. What is t2 minus t1? Now, what I'll do here is I'll write this as root 2 by g into root 2. What is t3 minus t2? It would be okay. I just took t2, right? I didn't take t1. Okay, so this is t2 minus t1. What is t1? T1 is root 2 by g. Similarly, is 2. What is t3? T3 is T3 minus T2 is root 3 into, okay, root 3 into right, this value what we're talking about, root 3 into root of 2 by g minus root 2 into root of 2 by g. Now, if you have a look at the equation here, what is common in every term? Root of 2 by g is common in every term, right? So this is common in every term. So what can we do? We can cancel off that term, and what do we get in terms of that? So what we get is 1 is to root 2 minus 1 is to root 3 minus root 2 is the required ratio, which marks our answer as option C. Option C. The distance moved by a freely falling body starting from rest during the first, second, and third second of its motion are proportional to. Before we start the actual solution, see, students always come to this conclusion: half s is equal to half g t1 square, which is equal to first. So s1 is equal to half into g into 1 square, which is equal to half g. And then they take second, which is s2 is equal to half into g into t2 square. Therefore, that becomes s2 is equal to half into g into 2 square, which is equal to okay, let me like this half into g into 4. And then they take the ratio, and then they get the ratio as 1 is to 4 is to 9, and so on. Okay. Now, why is this wrong? I'll tell you the point. See, S at, when you say S is equal to ut plus half at square, and when you put 2 here, what you do is, what you're trying to find out is distance traveled when time of observing the motion was 2 seconds. But when you say Sn S2, it means that it is the distance traveled in the second. Okay, so distance traveled in 2 seconds minus distance, or the distance traveled in the second. These two are different. Now, how are they different? We'll have a detailed look on that. Okay, so now let me make use of a diagram to explain you the concept here. So let us say this is a body which is under free fall. Let us say it starts with position O, A, then it's B, and later it is C. Okay, now you say this much was the distance traveled in t1 second, this much was the distance traveled in t2 seconds, and this much was a distance traveled in t3 seconds. Okay, so let me correspondingly mark them as h1, h2 and h3. Now see, what is given in the question is during the first second, third second and the first second and third second. So it is not s, it is just asked you, it is sn. So what is sn? I write it like this. Sn is the distance traveled in the nth second. All right, or second 2 is let me highlight this. So in the nth second. So Sn is the distance traveled in the nth second. Okay. In which case, what is S1 is equal to? S1 is the distance traveled in the, instead of n, what do we have? The first second. So we'll write it as first second. Let me highlight this portion also. Similarly, what is S2? S2 is the distance traveled in the second. Let me highlight that also. Second. And what is S3? S3 would be the distance traveled in the third second. Okay. Now, what is S1? What is the equation for S1? See, we're not going to discuss the derivation here. Anyway, so Sn is basically u plus a by 2 into 2n minus 1. This is the equation for the Sn, right? This is the equation for Sn. Why are we not discussing derivation? Because we are doing MCQ practice here, not a lecture for the school level physics. We are purely dealing with entrance level topics, so let us not go into the derivation part. Okay, now that we have discussed Sn is equal to u plus a by 2n minus 1, let me continue the problem here by writing S1 is equal to, to make the concept clear, we will rewrite the equation. Now, Sn is equal to, what is the equation? U plus a by 2 into 2n minus 1. Now, since the body is in free fall, from rest, right? From rest, what can we say? U is equal to 0 and A is equal to G. In which case, Sn here would be equal to G by 2 into 2n minus 1. So, what is S1? S1 is equal to G by 2 into, instead of, or let me write like this. What is S1? S1 is equal to S when n is equal to 1. G into 2 into 1 minus 1, which is equal to G by 2 into, what is 2 into 1? 2. 2 minus 1 is 1. So that it has G by 2 into 1. Similarly, what was the question asking about? First, second and third, right? Okay, so the second will be S2 is equal to, right? S2 is equal to S at n is equal to 2, which is equal to G by 2 into 2 minus 1, which is equal to G by 2 into, what is 2 into 2? 4. 4 minus 1 is 3. Okay. Similarly, what is S3 is equal to? S at, I lost, okay, first, second and third of seconds. Okay. So it is n is equal to 3, which is equal to G by 2 into 3 minus 1, which is equal to g by 2 into, what is 2 into 3? 6. What is 6 minus 1? This is 5. Now, what is that we've been asked to find out? The ratio of these distances, S1 is to S2 is to S3, which is equal to g by 2 is to g by 2 is to g by 2. And what are the remaining values? 1, 3 and 5. Now, if you remove the common ratios, what do we get? What we get is S1 is to S2 is to S3 is equal to 1 is to 3 is to 5. Now, so this is S1. Now, what is Sn? Sn is g by 2 into, so this actually proceeds like this. It goes on up till g by 2 into 2n minus 1. So, when we cancel out g by 2 from the entire ratios, what is left at the last ratio? It is 2n minus 1, which makes the final answer to be 1 is to 3 is to 5, etc. up to 2n minus 1, thus making the correct answer as option D. A body falls from height h is equal to 200 meter. The ratio of the distance travelled in each 2 seconds during t is equal to 0 to t is equal to 6 seconds is. So if we try to visualize and understand the question here, the body is dropped from O in time t is equal to 2 seconds. It reaches A. Okay. In time, say, in time t is equal to 4 seconds, it travels even further. Now, in time t is equal to 6 seconds, say it reaches C. So, this much distance is covered in 6 seconds. Now, if you try to overlap this value here, right? So, if you just keep this value here, we can use one diagram to explain all. A, B. So, this is at t is equal to 2. This is at t is equal to 0. This is at t is equal to 4. And this corresponds to t is equal to 6. Okay. Now, what is S1? Or say, what is S? S is distance traveled in time t. Okay. So, what is S at t is equal to 2? S at t is equal to 2 is equal to distance traveled in time. In time, what? In time t is equal to 2, right? In time t is equal to 2. Similarly, what is S4 is equal to? S4 is equal to St is equal to 4 is equal to distance traveled in time t is equal to 4 seconds, right? And what is St is equal to 6 implies? St is equal to 6 implies distance traveled in time t is equal to 6 seconds. All right. So now okay, let me give it a diagrammatic explanation also. So S at t is equal to 2 implies distance traveled in time 2 seconds, which means the body has traveled OA. St is equal to 4 implies the distance traveled in time t is equal to 4 seconds, which means it has traveled OP. Distance traveled is OP. Now S at t is equal to 6 implies the distance traveled in time t is equal to 6 seconds, which means the object was initially here. It has traveled this much long. It has traveled the distance OC during t is equal to 6 seconds. Now, let me take you to the mathematical part of this. Okay, so what is S1 is equal to? See, S1 from here is equal to, let us first write down the equation. So S is equal to ut plus half at square, we know, but since the body is in falling from rest, u is equal to 0, so S is equal to half into gt square is the equation that we are going to make use, right? So S is equal to half gt square is the equation. Now, what is S1? S1 is OA, right? And what is OA? OA is equal to half into G into T1 square. What is T1? Is equal to the first time interval, which is T is equal to 2. So this becomes half into G into 2 square, right? Now, what is S2? S2 is the second case where the body has traveled from O to B, right? Is the distance traveled is OB. Mathematically, from the figure we can say that OB is equal to OA plus AB. Distance traveled OB is equal to OA plus AB, which is equal to half into G into how long was the body in the air for? It was for 4 seconds. So this becomes T into 4 square, which is equal to half into G into 4 square. Now you should be able to complete the rest. So S3 is equal to OC is equal to half into G into how long was the body in the air for? 6 seconds. So this is 6 square, which is equal to half into G into 6 square. Okay. So, well, this basically reduces to G by 2 into G by 2 into G by 2 into G by 2 into 4, or this reduces to 2 square is 4, 4 by 2 is 2, so this is 2g. 4 square is 16, 16 by 2 is 8, so this is 8g. 6 square is 36, 36 by 2 is 18g, right? Now let's see. Let me now introduce distance traveled OA as H1 for ease of calculation, distance traveled OB as H2, and distance traveled distance traveled as H1, AB as H2, and BC as H3. Now, if see from the figure, if OA is equal to 2g, what does that implies? It implies that H1 is equal to 2g, right? Now, if OB is equal to 8g, what does that imply from the figure? What is OB? OB is H1 plus H2. So we have again OB is OA plus AB. I think we should write down that part also. Okay. So next is OB is equal to 8g. But what is OB? OB is OA plus AB. So if OA plus AB is equal to 8g, we can write that H1 plus H2 is equal to 8g. Now, using these two equations, what is H2 is equal to? H2 is equal to 8g minus H1. What is H1 is equal to 2g? So H2 is equal to 8g minus 2g, and therefore H2 is equal to 6g, right? Similarly, what is OC? OC is equal to 18g. is equal to 18G. But what is OC? OC is OA plus OB plus BC, which is equal to 18G. From the figure, we have the corresponding value H1 plus H2 plus H3 is equal to 18G. But what is H1 plus H2 is equal to 8G. So we can replace H1 plus H2 here by 8G. So we have 8G plus H3 is equal to 18G. In which case, what is the value of H3? H3 will be equal to 18G minus 8G, which is 10G. So H1 is 2G, right? H1 is to H2 is to H3 here would be equal to 2G is to what is H2 is 6G is to what is H3 is 10G, which is equal to 1 is to 3 is to 5, which makes the required answer as option C. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds respectively. The relationship between h1, h2 and h3 are. Okay. Almost a very similar question. So if we try to understand, okay, let us not skip the explanation. Let us consider that as a fresh question. So this is distance covered in first 5 seconds. This is the distance covered in the next 5 seconds. And this much is the distance covered in the next 5 seconds. Okay. So this much is at t is equal to 5. This much distance is at t is equal to another 5, which is t is equal to 10 seconds. And this much is at another 5 seconds, which is t is at 15 seconds, right? So what is S1? See, what is S is equal to? S is ut plus half at square. Since it is from rest, S is equal to half gt square. So what is S1 is equal to? Half into g into 5 square. What is S2 is equal to? Half into g into 10 square. And what is S3 is equal to? Half into g into 15 square. So this will be equal to g by 2 into this will be equal to g by 2 into equal to g by 2 into 5 square is 25, 10 square is 100 and 15 square is 225. Okay. Now coming on to the solution part. See, OA, let OA be H1, let OB be, let this much distance be H2, let this distance be H3. Now, what is S? Okay, what is S1? S1 is basically OA, right? So S1 is equal to OA is equal to H1 is equal to G by 2 into 25. What is S2? S2 is distance traveled in the 10 seconds, which is this much OB. What is OB from the figure? It is OA plus AB. See, if this is OA, this much is OA, then OB will be OA plus AB, which is equal to H1 plus H2. But what is S2? S2 is G by 2 into 100. Very similarly, what is S3? S3 is equal to this complete distance, which is basically the sum of OA plus AB plus BC, right? Which is OA plus AB plus BC, which is equal to H1 plus H2 plus H3, which is equal to G by 2 into 225. Now it's just linear equation, but I'll try to solve that also. So let me write down the equations first. So h1 is equal to, now see what I'll do is I'll consider g by 2 as x. Okay, so h1 is equal to 25x, h1 plus h2 is equal to 100x, and right away from these two equations, what is, let me solve that. So since h1 is 25x, I can write here that 25x plus h2 is equal to 100x, and what is h2 is equal to 100x minus 25x, which is equal to 75x. So h1 is 25x and h2 is 75x. Okay, now what is the third relationship? h1 plus h2 plus h3 is equal to 225x. But what is h1 plus h2? It is 100x. So we have 100x plus h3 is equal to 225x. In which case, what is h3 is equal to 225 minus 100, which is 125x. Now, I'll write down the equations like this. h1 is equal to 25x. h2 is equal to, h2 is equal to 75, which I'll write it as 3 into h2 is equal to 75x, which is, I'll write it as 3 into 25x, and h3 I'll write it as, what is h3? 125x, which I'll write it as 5 into 25x. Now why did I use 25x? I'll tell you. See, what is 25x? h1, right? So this basically reduces to 3 into, what is 25x? h1. This is 5 into, what is 25x? Again h1, right? So if you look at the relationship here, what we have reduced so far, it reduces to h1 is equal to 25x, h2 is equal to 3h1, and h3 is equal to 5h1. So h2 is equal to 3h1 implies h1 is equal to h2 by 3. h3 is equal to 5h1 implies h1 is equal to h3 by 5, which makes us to the equation h1 is equal to h2 by 3, right? From here we have h1 is equal to h3 by 5. Therefore, the correct option would be option C.